Hey guys, this is Mrs. Vaquero and Kiwi here. Kiwi's actually right down there doing the videotaping for me. And we're here to finish up a science lab that we started last week on how sound is made from vibration. And each of you should have a lab sheet that looks like this in your journal. So if you guys will open up to that page for me. And if at any time you need to consider a question or take some more time to answer it, feel free to pause this video. Okay, so we're pulling out sound as vibration. And last week we got to answer the first couple of questions here. And I'm just going to review those quickly for anybody who is absent or if you've forgotten what we discussed. So what do all sounds have in common? Think of those instruments that I played. I played the djembe drum for you. I played my guitar. We played the tin whistle, the didgeridoo, that long African instrument, and my trumpet from my Georgia Tech marching band days. So what do all sounds have in common? Okay, and if you didn't already write it last week, you should have written that all sounds are caused by vibrations. Okay, and we got to see a lot of vibrating objects last week, and you guys described for me that vibrating objects looked like they were shaking back and forth. Some of them moved so quickly that they looked blurry. Okay, some of you said they were wiggly. And when you guys felt vibration, some of you said it feels weird. And we said we wanted to be a little bit more scientific in our description. So besides just feeling weird, you guys might have felt that it tickled your hands. Maybe it felt like buzzing against your hands or your skin. Okay, definitely some movement there. And that's about all we had time to answer last time. And this time I want us to finish up by starting with number 4, the rubber band on the ruler with the pencil. They called it in your lab sheet the miniature ukulele. And right here you can see I've got one built. I'm going to let Kiwi videotape for me while I demonstrate it. Okay, so Kiwi, just hold that right there. And the question on your lab sheet asks you to describe the difference in sound when you pluck the rubber band when it's long. So you see the distance between where the pencil is holding the rubber band and the end of the ruler is really long. So listen to this sound. That's about the tone it's making. And then when I shorten it up and I play on the short side, it's about that tone. So you can hear the pitch is actually what's changing. So I'll play it one more time for you. And this is the same idea as on my guitar. When I press down the strings on the guitar, I'm changing the length of the string, and when they're shorter, they make a higher pitch sound, and when they're longer, they make a lower pitch sound. Okay, so on our lab sheets, let's just take a minute to answer number 4, and you can pause the video if you need more time than I give you here. Describe the change in sound when you move the pencil and change the length of the rubber band. Okay. When the rubber band is longer, what's that word to describe the highness and the lowness of sound? If you said pitch, you're right. The pitch is lower or higher when it's a longer string. I'm going to let you guys fill that in on your own from what you just saw. Okay, and of course the opposite will be true when the rubber band is shortened. The pitch gets, and you need to fill in either higher or lower there, whichever one's true. And if you need longer, just pause this video. Okay. Next, we did the ping pong ball and the tuning fork, but we didn't have time to answer that question on our lab sheet, so I'm going to ask you guys to answer that now. And I'm going to do that demonstration for you. Here I have the tuning fork, okay, and a ping pong ball that's on a string. And I'm going to hold it right up here, and I'm going to start by hitting the tuning fork on my knee. Get it going really good there. And holding it to the ping pong ball. And as you can see, it bounces the ping pong ball. The question is asking why. Oh, that was a good one. Why does that happen? Okay. This time I'm just going to hold it up, and the tuning fork actually is making a sound right now. I can hear it. You may not be able to hear it on the video, but we know that all sounds are caused by, if you said vibrations, you're right. Okay, so we're going to put those away. And actually, before I put it completely away, let me just show you one more demonstration with the tuning fork, and you guys each got to do this last week as well. I've got a bowl full of water here, and again I'm vibrating the tuning fork, and take a look. Do you guys see those ripples? I'll do it one more time. We know that even though the tuning fork is not vibrating fast enough for us to see very well with just our eyes, we can see that it actually splashes that water and causes some ripples when you dip it in. It's the same reason it bounced the ball. Okay, so we're going to answer question number 5 now on our sheet. What caused the ping pong ball to bounce away from the tuning fork? The tuning fork was vibrating. Okay. And it's hard to believe when you see a tuning fork because sometimes it's so fast, again, you can't even see it moving, but it really is vibrating, and that's what makes the sound when you hit it. Okay. And I'd like everybody to take a minute to think about number 6 with me. I'm going to give you about 30 seconds just to sit super quietly and listen to what you can hear in the room. Okay, and that was about 30 seconds. So what did you hear while you were sitting there? Okay, if I had to guess, you might have heard some breathing, you might have heard some giggling or whispering if somebody wasn't completely quiet. But write down a list for me of what you heard and what's causing those sounds, and why is it that you can hear them. Okay, and while I was sitting here, I heard the clock ticking. And I also heard a teacher down the hall teaching. I'm just going to have to set this down for a second to write. Okay. And those sounds actually vibrated the air, and sound waves traveled to my eardrums, and that's why I can hear them. Now I can hear the air conditioning. Sorry about shaking back and forth here, guys. I'm trying to write at the same time as holding it. That's better. The sound waves traveled through the air to my eardrums. Okay, so take just a minute to answer that question yourself, and then write down a question or two that you might be wondering now. And that's it for this video. Next, you're going to play the next video to learn how to make your own instrument. So if you need longer on this video, just pause it, and we'll pick up with our instrument lesson next.